Good morning. How is everyone? Enjoying SUSECON so far? Good, good. Well, again, welcome to our session. This is a closer look at, as the title says, leading with Linux, but more specifically, this is going to be a conversation around how to modernize core business applications using Linux, open source technology, and of course some of the tools that Stefan and I will discuss here today. So again, welcome. Thanks for joining us today. My name is Ed Airy. This is Stefan Tosis. We're both very happy to have you with us. Our conversation for today is going to try to follow this model, try to follow this agenda. We'll talk a little bit about what's driving change in the industry today, what's driving organizations to think a little bit differently about enterprise applications and how to address them. We'll talk about some of the options they have in terms of modernization. What are the perhaps most common options that are out there? And then we'll take a closer look at the profile itself. So not every application is appropriate for this type of technique, this type of modernization. So we'll talk about what makes a good and perhaps a not so good candidate. And then we're going to talk a little bit about the underlying foundations, if you will, of modernization, effectively the hardware environment itself. So Stefan will come in and talk a little bit about why LinuxONE and why that is a good platform to target for this type of technique. And then we'll talk about tools and some customer use cases and wrap up with how you can get started if this is something that's of interest to you. So hopefully that sounds interesting for folks here. Thank you for joining us, and let's get started. As I mentioned, I'm from Micro Focus. My responsibility is in our application modernization practice, so I manage the tools and the technologies in that division. Stefan, as many probably know, is a staple here at SUSECON. He works for IBM. In our R&D labs and is the LinuxONE offering manager. So I know you've got a session later on today on that as well. So together we're going to share with you our insights and sort of our experience in this space, and we hope we can make this interactive too. So if you have questions, please feel free to shout them out. We'll try to take as many as we can. So let's begin with a closer look at some of the, let's just say, barriers to change, what's driving change in the industry right now. And let's start with a very common scenario, very common situation. Most IT shops today, or most business organizations, have started with typically one or very few platforms of choice, business applications of choice. And for most organizations, but not all, these have resided on mainframe technologies. These have resided on what some call legacy systems. But for all intents and purposes, they've been very successful. They've been able to leverage those environments to scale their business, reach new customers, deliver new services. But what we've seen over the last 40 or 50 years is actually really quite interesting. We've seen this rapid pace of innovation and change take place. We've seen new technologies come in and out of favor. And there's been some great returns, right, for business and IT as a result of embracing some of those technologies, whether it was client-server or the internet and now certainly cloud, mobile, and IoT. There's always something new advancing the wave. But very, very seldomly do we see that IT has replaced the former systems with the new technology, right? It's usually in addition to what they have. And what we tend to find when we talk to our customers and folks in the industry is that the average IT estate tends to look a little bit more like this, with branching connections, different systems integrating and working with each other, a very, very complex environment. Does anyone sort of relate to this graphic at all? Sort of say this looks like a little bit like my IT environment? Well, this makes change and understanding, modernizing these systems very challenging for organizations because many just don't know where to begin. There's a lot of risk, right? There's a lot of potential to do something wrong that might disrupt the business. But within this application estate, if you will, there's a lot of IP, intellectual property, there's a lot of value. So how do you unlock that value and extend it, take it forward? Now, when you add this backdrop to what's also happening in the industry right now, you get a better appreciation for just how much pressure IT is under. See, the new expectation is that IT is going to magically find new ways to deliver faster, right? They're going to find ways to accelerate the delivery of new services, new capabilities to customers. They're going to find a way to become much more efficient. They're going to embrace the digital age and be able to deliver new services on mobile devices, on tablet computers, on smartphones, reach the digital consumer, customize content, and find new ways to embrace the customer experience by delivering always something new, delivering a new capability. Well, that's a tall ask for IT organizations, given the backdrop we just saw, and the reality that many organizations today continue to focus on a lights-on strategy. Most organizations are focused on keeping that business running. That infrastructure we saw a moment ago, that's occupying a majority of their time, their energy, their budget, their resource. So what does that mean? Well, it leaves not a lot of time or money or energy for next generation innovation, right? That the new things that we're asked to do, the new things, whether it be cloud or mobile or expanding our existing application environment, maybe going into new markets, there just isn't time to do that. So how do you bridge the two together? How do you shift the equation so that you're spending more time on innovation and less on operational maintenance? Well, this is particularly where these systems of record come into play. And that's what we want to talk to you about here today, is how to extend the value of these, what some would call established application environments, extend the value of these systems forward into the future, leading with Linux. So being able to leverage SUSE Linux technology, some of the tools and capabilities we're going to talk about here today to allow you to extend these applications into the future. But there's barriers. There's barriers to doing that, and we're going to talk about how to break through some of those barriers. One of the first ones that comes up almost immediately when we start talking about those brands is skills. How many here have Unisys mainframe skills? I didn't think there would be many. Or those similar types of skill sets, they're hard to find in the industry. Hard to find organizations and people that can support those applications. They're very costly to support in many cases, very challenging to modify, to change. There's a lot of risk in those systems. Why? Because they've been around for 50, 60 years. We have organizations like the IRS, organizations like big banking institutions that are using these types of platforms to power their business. But change, yes, it continues, but those systems are critical to the functionality of the business. But that makes them inflexible in many ways to change, particularly the rapid pace of change that we mentioned a moment ago. That new expectation that the business now has on IT to find a way to move faster. Well, how do you do that if you're tied, if you're shackled to these old ways of delivering services? We need to find a way to reduce the complexity, simplify the estate, give us more options, more mobility, and give us more choice as we look to deliver those new services. So, sounds pretty good, right? So how do we break through some of those challenges? What are our options? Well, let's talk about some of those options. Now, one of the best ways to do this is talk a little bit about a research report in a group known as the Standish Group, Standish Research Group. Has anyone heard of Standish in this room? They publish a report annually called the Chaos Report. It's pretty easy to find online. I'd encourage you to take a look at it. It's called the Chaos Report. And what they do is they measure and monitor application modernization projects across the globe. So they typically, their sample size is anywhere between 1,200 to 2,000, somewhere around there, application modernization projects. And what they look for is effectively, was the project delivered on time, on budget, and did it meet end user expectations? Those are the criteria that it uses to determine was it successful. So using that sort of model, we took a look at, well, what do organizations typically do? And this is what Standish advises, is that in the majority of cases where organizations attempt to rewrite those core business systems to, let's say, a different language, different architecture, it's not that they're not successful. Many are successful, but very, very few are successful in terms of delivering on time, on budget, and meeting expectations. There's lots of scope creep, lots of budget expenses that go in that change the dynamics of the projects. The same is true for application rewrite. Yes, the risk is a bit lower because you're buying a package, if you will. You're buying almost a self-contained unit, functionality. But you have the same challenges in terms of implementation, on delivery times, on meeting expectations of the business user. So this is where Standish says the most successful in modernizing business systems are those that are able to leverage what they have, reuse their core business applications in a new way, unlocking that functionality. So that's effectively what we're talking about here today, is how do we unlock that capability. Now, a retailer in the UK performed a very similar study to what Stan just did here. This retailer was looking to enter a new market in the US, and it was a highly competitive market in the grocery business. And they looked at modernizing their core business applications through rewrite, through replacement, and then through an extension technology, extension capability through reuse and modernization. But they analyzed those three capabilities across 4 different dynamics. And these are the dynamics here: over cost, over risk, over time to delivery, and last but not least, over competitive advantage or competitive IP. And yes, it's probably no surprise that reuse was less costly, less risky to the business. It may even got them to market a bit faster than other alternatives. But interestingly enough, that wasn't the reason that this retailer chose to reuse their core business systems. The reason they chose to stay with that approach is it enabled them to preserve 100% of what made them unique in the market. 100%. So how valuable is that to an organization entering a new market where they know it's highly competitive if they can leverage exactly what's made them successful up to this point? 100% of their IP. That was why they chose to approach this model. And yes, they are certainly able to achieve some cost savings along the way. Well, this is precisely what Micro Focus and IBM have been helping customers do together for the last 40 years. We have a great relationship, 2 organizations working together to help modernize core business systems. You're going to get an opportunity shortly to hear from Stefan on why LinuxONE. What are some of the new innovations within that technology that make it unique, particularly for enterprise workloads. Micro Focus is primarily, its core capability is around development tool sets, modernization tool sets. As I said, we've been working with IBM since the very early days in 1976 in supporting IBM mainframe technology to be able to give you choice around modernization. So let's talk about that profile. Let's talk about what does it look like? What does a good candidate look like if we're going to modernize enterprise applications? So it was kind of nice of Aaron to mention this during the keynote. He kind of teed this up quite nicely for us here. We're just going to talk about black and green screens, because that's exactly what we're going to talk about. This is the typical profile of those established core applications. Many of them have been in place for 30, 40, 50 years, running on legacy hardware that's very challenging to acquire parts for, let alone skills. We're talking about millions of lines of code that are running in production, many of them written in legacy languages such as COBOL or ALGOL, similar technologies. Database structure, not very similar to what we would expect to see today, nothing like relational, nothing like NoSQL. They don't have those capabilities. And again, the classic user experience of the green screen, right? So this makes a great candidate to talk about how do we modernize these applications? How do we transform them, put you in a position to be able to modernize using Linux as the foundation? Let's take a closer look at those components. See, first we have to understand that it's more than just code. There's a lot going on here when we talk about the inventory of enterprise applications. Yes, there's lots of ways in which we could convert code. We'll talk about that in a moment in terms of mapping a source environment to a target environment. You have lots of choices there. But there's a lot more going on, a lot more intricacy and componentry involved. It could be secondary languages, transaction processing systems, batch infrastructure, online infrastructure, data models, data tools, backup, all sorts of things that come into play that need to be considered if you're going to start moving enterprise workloads to a new environment. Lots of ways to do it, lots of different approaches as to how to best achieve it, but unless you have a plan for all of these components, you won't be successful. So you have to understand that there are many different aspects here when we talk about moving these workloads. And this is precisely where, as Stefan will explain, LinuxONE is the right solution for helping you port those environments that have this complexity. So let's take a look at an example. Okay, let's take a look at what it looks like going from a source environment, let's say a Unisys mainframe, to something more modern. Maybe some distributed architecture running on SUSE Enterprise Linux. Maybe there's a combination of open source technology. Maybe there's some established proprietary technology involved. Let's take a closer look at that mapping. So it's pretty straightforward. If you take a look on the left-hand side, that's your traditional stack. If you're living in a Unisys world, a mainframe world. On the right-hand side is an example of where you could take the technology on the left. As I said, there's lots of flexibility here. You could design the right-hand side to be completely open source if that's your desire, or you can mix and match, depending on what's important to you, what's strategic to you in your organization. Very, very commonly, though, what organizations try to do is to limit the amount of change with that rehost, with that replatform activity. What does that mean? The less change you introduce, the less risk. The better chances of success, the better chances of reaching your project's goal in terms of budget and risk, and time to market. So emulation technologies play an important role, whether it be emulating fourth generation languages or even emulating some of the legacy technologies that are out there that might be transaction processing systems and alike. These systems effectively mirror what's taking place on the Unisys environment in an open source world, allow you to perform the same capabilities without change to the underlying infrastructure or code. But for some, they want to convert those applications. They want to convert the code to perhaps something that they're more familiar with. They want to use modern tools to do it. So there's certainly lots of choices here. You could move Algol to Java, to modern versions of COBOL, to any sort of language you think is strategic for you. As I said, most of these applications we're talking about do have a common denominator. Most of them are running some version of COBOL. Unisys had a dialect of COBOL called Unisys COBOL, but there's lots of other variants as well. And you typically tend to see millions of lines of this code. Some have converted it to Java, but there's other technology we'll talk about momentarily that allows you to compile this to the JVM, allows you to integrate COBOL with your JVM stack. And that's exactly what we're talking about there with Visual COBOL. But you have lots of different options in terms of where you take your technology, whether you're talking about Mapper and Link, which are infrastructure components, transaction processing components, lots of options in terms of how you want to take those forward. WIFL and ECL, think of those as job control languages, so ways in which we can orchestrate tasks. And then, of course, there's the database question, the data model question. Is anyone here familiar with DMS2 on the Unisys environment? Very popular database when Unisys launched this platform, but it's not a skill set that many have today. Hierarchical database structure, or even perhaps in other cases more challenging, flat file database structure. Lots of choices here in moving perhaps DB2, LUW, perhaps moving to MariaDB, perhaps moving to a NoSQL alternative. Lots of choices. But the key factor is, of course, we're driving this entire engine on SUSE Linux because it gives us portability, it gives us that adaptability to change. So if we decide later on that we want to perhaps move to a relational database today, but NoSQL is a strategy tomorrow, we can swap it out. We can change the dynamics of our architecture without modifying the service. That's a very important aspect here. It gives you flexibility and adaptability to move much faster. But what about the hardware? We haven't talked about the hardware. Lots of choices here in modifying the software, and we'll come back to this in a moment, but what do we do with the hardware? In many ways, this is the limitation. This is why organizations haven't moved, is because, well, these systems were designed for high performance. They were designed for speed. They were designed for resiliency. Are we going to get the same type of capability if we start changing, altering the hardware? These are just two examples of what you would expect to see in a Unisys mainframe world. Very, very common platforms. But there's an answer. There's actually a great answer. And this is why Stefan is here. He's going to talk a little bit about why LinuxONE and why LinuxONE makes for a great strategy for underpinning enterprise application workloads.
Okay, can you hear me? Yes. Okay, this is the laser. So thanks, Ed. So my name is Stefan Toss. I'm from the IBM Development Lab in Böblingen, and I'm the offering manager for products like LinuxONE Systems, KVM for IBM C, CVM, who knows CVM? The hypervisor, and also Wave. And what I want to show you in the next slides is, as Ed mentioned, what could be a target platform for you when you modernize your IT environment, right? I'm talking about LinuxONE. First of all, you might have heard about our positioning for LinuxONE and Linux and IBM C systems. So we actually created a new brand, which is called LinuxONE, to really have a new discussion with customers about a hardware platform which is suiting Linux and open source technologies in a long time. So as you heard this morning in the keynote, SUSE and IBM is working together since 15 years and really with Linux on the mainframe. Actually, the first SUSE enterprise distribution was on the mainframe, not on x86. Right? So for our existing customers, we have C systems, also with COS operating system. You can also run Linux there, but we target also new customers, especially customers Ed was talking about who want to modernize their environment with LinuxONE. From a technology point of view, they are currently similar, it's the same technology, but underneath we have different marketing and different messaging. Right? So if you are a mainframe customer with IBM, and you have COS in your shop and you want to run Linux, you can do this as well. If you want to run Linux only workload, then you use LinuxONE. It's kind of more like a positioning and marketing. From a technology point of view, it's the same thing. What I show here is really who is using Linux on the mainframe. And as we released LinuxONE last year, we get customers and we get adoption, but this is mainly showing the story for Linux on the mainframe. What we see here is a constant growth of IFL capacity, which means really Linux capacity on the mainframe. And what we also see is that nearly 50% of all systems have IFLs installed, so 50% of all mainframe customers are using it. 92 of our top 100 C customers are using Linux. So Linux is really an important part of the IBM mainframe strategy. So a lot of COS customers even grow on the platform because of Linux, because they can put now new workload on Linux on the same box. I talk about that a little bit later. So it's a quite good success story with the majority of our customers really using Linux. And as I said, SUSE is one of our partners. We also support two other distribution partners on the platform. Who is using Linux on C and LinuxONE? Here you see kind of, okay, what is the industries, and it's mainly in government, insurance, and financial sector. This also depends a little bit on in which geography you are. So we're very successful in North America, Europe, in the financial sector, but also in different geographies, like in Asia, we are more successful in other areas. So our major markets are really Europe and North America, with a growing segment in Asia as well. And we have small installations with only 2 IFLs. So an IFL, think about it as a processor. Talk about that later a little bit. Up to customers with, I think, nearly 1,000 IFLs. So one customer is running 1,000 IFLs. So we have all different sizes, right? We have a different variety. Okay, well, this is kind of a study from I think the one is from ITIC about hardware failure. And one of the key value propositions for the mainframe, for C systems, and for LinuxONE is really the design of the platform. The platform is designed in a way that is very high availability. All right, and what you see here is different vendors from different platforms. About unplanned downtimes, how many unplanned downtimes they had from a different platform. What they find out, IBM C systems really had 0% of it, right? It happens, but really, really seldom that the customers had an unplanned downtime, because the system itself is designed in a way, from a hardware point of view, that you really can build it up, especially if you cluster the environment, that you can have 0 downtime, just from a hardware perspective. And then also there was an IDC study where they said, okay, customers leveraging C systems and LinuxONE, how did the unplanned downtime instances per year, time to resolve unplanned down, how did this change? And you really see the improvements by customers moving to this environment. I have to drink a little bit in between. I'm suffering a little bit from a cold, which I think is not getting better in this room. So there is really a lot of benefit from the hardware platform itself about reliability, and this explains also the customers that you've seen before, governments, insurance, financial industries, they really choose these environments because they dependent on their hardware and software stack running on top of it. Right? This gives an overview how IBM expanded these systems over the years. So you have here our systems, the naming C9, C10, C196, and our current system C13. And what you see here on these is how these systems getting bigger and bigger. And interesting here is, if you look at the number of cores, of CPUs, that enhanced in the beginning quite rapidly, but not so much anymore. Right? There was a much bigger demand in terms of memory. Right? In the beginning, the system only had 1.5 terabyte, 3 terabyte, and from EC12 to C13, we jumped to 10 terabyte. And you will see that trend because there's more and more requirements for more memory on database. First of all, for in-memory databases, and secondly, also in this gap here, more memory, you can put much more virtual machines on that system. It allows you to put a large number of virtual machines, which could be obviously Linux, but also COS, CVM, our traditional CVM's the hypervisor operating systems on. And we also did a lot of increasement in I/O bandwidth on the whole system. So this really talks about one systems where the combined I/O bandwidth is up to 832 gigabyte per second. So we will not see much more expansion in this area. Yes, we see more and more cores, but the bigger enhancements are in memory and also in I/O bandwidth. Okay, going back to LinuxONE, we have two offerings. One is called Emperor, which is the big system, and LinuxONE Rockhopper, which is kind of an entry point, smaller system. And the next chart really gives a little bit details about how these systems are. So it's really one system, no built-in storage. It's just including I/O adapters, including CPU and memory. So the big system, the Emperor system has up to 141 CPUs, up to 10 terabyte memory, data compression built in, and already in the hardware 8 logical partitions. So you can already run on the hardware 80 different logical partitions. So it's virtualized on the hardware level already. So it's I think since 4 or 5 machine generations, there is no mode where you can just run one operating system on one box. It is virtualized already on that level, which means you can also share memory, CPUs. You can divide your 10 terabyte of memory between these logical partitions. You can share CPU resources between these logical partitions. You can dedicate CPU resources to one of these logical partitions, or you can have it even mixed. Even I/O capacity can be dedicated or shared between these logical partitions, depending on your workload needs. So you might have a logical partition which has your primary database servers, and you always want to have the best response time for the server, so you better dedicate resources to this logical partition. The smaller systems, the entry point system is the Rockhopper with only 20 CPUs and 4 terabyte memory. I go a little bit more into detail. I mentioned that already. So on the box with up to 140 CPUs, you have a virtualization on the hardware level with partitions, up to 80 on the big system. But in each of these logical partitions, you can run a hypervisor again. Right, we have KVM for IBM C now on the platform. We have CVM, which is a hypervisor, which is in the market since more than 40 years. So in each of these partitions, you can run either a Linux directly, or an hypervisor, and under this hypervisor, again, Linux systems, depending on what your needs are. Think about a development environment, and you as a customer have a lot of developers. Everybody wants his own Linux system. You rather choose taking a hypervisor here and bringing up a lot of small Linux development environments. If you want to run a production system, you maybe choose taking a logical partition, putting a Linux in there, and run your application inside of this logical partition. So you really have the choice. So in comparison to the commodity x86 world, we know you have hardware, you can have a hypervisor, VMware, KVM, Xen, whatever's you know it, and run your virtual machines on top of each of these boxes. As I said, and this is actually a lot of customers did it, they consolidated such an environment to a LinuxONE or mainframe environment, because the system itself is so huge, it can really consolidate a large number of x86 servers in one box. Just think about the networking. We have a very in internal networking. It's kind of a memory-to-memory copy from logical partition to logical partition with a high speed. So you save all these cabling and also security flaws by having a network switch, which is necessary here, let's say, between these systems. What's nice about LinuxONE and C systems is you can scale horizontal and also vertical. So you can scale up, let's say, one virtual machine up to 141 cores if you want, if it makes sense, out to 10 terabyte memory. Or you can also scale horizontal, that you have a lot of small virtual machines on one box, either with CVM as a hypervisor or KVM as a hypervisor. Or you can do both. Right? The system is built up and there's tooling built in CVM, KVM together with SUSE Linux, where this can be done even automatically. So there's something for Linux, it's called collaborative memory management, for instance. So you start your Linux instance with a small amount of memory and it's growing automatically if there's more memory demanded. Right? It's just an example for technology which is built into this environment. This is also the key factor. We're working together with SUSE since a long time. We share our hardware technology with them upfront. We share our architecture, and they can also plug in stuff in their SUSE enterprise distribution, which supports this environment, working really close together with our hypervisors and hardware. This is what our competitive office did. It's some years old, but it still applies. What if, and I think a lot of customers do this today, what if you put an high priority workload together with some low priority workload on one system? You want to run this in parallel because times are over that you can afford for each service its own server, right? You don't want to do this because it's not cost effective. And the blue one is really the high priority workload, and now we put in some low priority workload in between. Let's think about some development servers. So we have 2, 3, or in that case, I think it was 10 virtual machines with some high priority workload, and they put it in some 14 virtual machines with low priority workload, some development systems low utilized. And the system is really built in the way, because of how the caching and the CPUs are put together, that it really fits into these gaps of the high priority workload. So the high priority workload has no impacts. You get the same throughput than you would get without these systems. On the x86 environment, you see an impact from these low utilized workloads also on the high priority workload, right? I give a little bit more details in a matter of time in my session on 2 o'clock today, but this is one of the key differences. And we have customers running at nearly 100% CPU load without any problem. So the C systems environment is built for that. Okay, I skipped that one. You can have spare capacity. So you buy processors. It is kind of funny, you buy the system and pay for CPUs, but there actually are more CPUs built into the hardware, so which enables you to have spare capacity. So if you have a demand for higher CPU resource for a given amount of time, you can enable that for a lower price. And just think about if your end of year data processing, where you need more CPU resources. I guess we have more time in this session and 2 o'clock. This is about the history between SUSE or how long we're on the market already. And what you see really here is the growth of our MIPS capacity. And SUSE was really one of the first partners who worked together with us to bring Linux on the mainframe, right? We also have Red Hat. We work recently also with Ubuntu. Oracle is a big play on our platform. Most of the IBM software is supported on Linux on the mainframe. So it really, you see, and we're putting more and more solutions on top of that. So it's kind of a success story, which we expand now also with LinuxONE. And as Ed mentioned, Micro Focus also has his tooling. He will talk about later about available on this platform with Linux. So it provides you really one of the options if you want to modernize your environment. You can't read this, but this is kind of the history. So again, we work since more than 16 years together between SUSE and IBM. Very good relationship. I have to say the best relationship between all 3 distribution partners. I can really say this. I talked about the virtualization options. We talked about and it's called Prism, the virtualization on the hardware level. Remember, we can have 80 up to 80 virtual environments on the hardware. On top of that, you can run CVM, which is a hypervisor in the market since 40 years. And recently, last year, we announced also having KVM on the platform so that customers coming from an x86 environment and not familiar with CVM have a very easy onboarding on platform with KVM. So you have different virtualization options. In terms of applications, as I said, majority of the IBM software is running on it with all three distributions. But recently, you might have seen a lot of investment also from IBM into enabling more and more open source software on the platform. Right? So if you look at, for instance, systems of record database, you have the big players like Oracle, IBM, but you also recently have a lot of these new open source database like MariaDB, MongoDB, and we also work with SUSE together to get more and more of these new open source technology included in the SUSE Linux Enterprise Server, which is fully supported from SUSE and also from IBM on the platform. And also systems insights, virtualization technologies, and so you get more and more choice that really improved for the mainframe platform, I would say, in the last 5 years. Okay, I raced a little bit quickly through that. Again, 2 o'clock, I have a session together with Markus Kraft from SUSE, where we go a little bit more into detail, focus completely on our relationship and Linux and on the mainframe and LinuxONE. And with that, I would give back to Ed.
Thank you. All right, thank you, Stefan. So you can get a little appreciation now for the importance of a solid underlying infrastructure, solid underlying hardware environment. I mean, this is the foundation, if you will, for rehosting, for modernizing these applications. So let's come back now and talk about some of the tools that help make that happen. So tools that you perhaps already know, are familiar with, and tools that you can leverage to help accelerate this pace of change. Let's talk about this process, if you will, of planning, building, testing, deploying, and of course extending, because that's what we want to do, is extend this even further from where it is today. So let's start with, I think, a really good spot, which is typically the beginning. How do we get to our destination? Well, we first need to know where we are, right? We need to have a map. We need to have GPS. We need a way of getting to our desired goal. Well, that's precisely what these types of tools enable you to do. To understand your application source code, the repository itself, that portfolio, not only to understand the relationships between program A and program B and program C. Yes, that's very important. But we also want to understand the impact of change. So if you decide to change one module, what do I need to change downstream? How big is that effort going to be? How many variables, how many parameters are affected? What's the relationship between one program and another if I start implementing changes? This gives us powerful information to understand when we start to evolve and change and modify this application, what development skills are going to be required, what tools, what technologies. And this is very important because that type of knowledge that you're gaining here is then instantly acted upon because it's integrated into a development tool set. A development tool set that's not only visual, but based on Eclipse. So now you can instantly take that code change, those parameters, those necessary changes that you needed to make, and act on them using these tools. Tools that you already know, tools that have built-in debugging capability, tools that now can combine perhaps some of the legacy languages that you were working with before with next-generation languages such as Java, Perl, Ruby, and other languages you're familiar with. You can do it all from within one tool set. Instantly edit, compile, debug, and test those applications. A very, very important concept because as you integrate and implement greater automation, what happens? You can start to move faster with predictability, with confidence, with less risk. So that's what we're talking about, is chaining these tools together so they work in an efficient way. So as you start to modernize and modify millions of lines of code, you can do this in a predictable way. But what about deployment? We need choices here, right? We talked about deploying to enterprise Linux, SUSE Enterprise Linux. That's certainly the platform, but what's the infrastructure going to look like? Well, if we go back to our example of Unisys applications and what that stack looked like on the left-hand side, remember that stack of software? The majority of these applications are written in COBOL. That's just the reality. Most of them are written in COBOL. So what are our choices there? Well, you can stay with what you have if you want. You can stay in native code and continue to deploy that to the JVM, deploy it to SUSE Linux as you wish. Or alternatively, you have an option now to compile that code as Java bytecode. Compile those legacy languages as Java bytecode running under the JVM. So now it lives and acts and behaves just like any other language operating within the JVM. The files themselves are Java class files. So any Java developer working with those applications can now instantly integrate with them in a language, in a tool set, and a framework they understand. So you have lots of powerful choices here. And I know the graphic on the far right is a bit hard to read from the back, but this is extensibility. This is the power of that tool set, is now you can integrate with almost any technology, open or proprietary on the market. These are the building blocks for application modernization. Solid tools that allow you to integrate faster by improving that efficiency of planning, building, testing, deploying, but built on a solid foundation. As Stefan explained, a solid foundation such as LinuxONE that gives you the ability to scale out and scale up, gives you that performance, that elasticity of resources, because these are enterprise workloads. They're always on, so they have to perform. Couple that with the experience of the teams that know how to do this. So not everyone understands the changes that have to go on in some of these applications to achieve those goals. So you need some expertise. Infrastructure expertise, yes, to perform the right aspects of tuning on the hardware and on the software, but then also the transformation of the code itself, the tooling that's required to transform the code so you can achieve those goals. These are the basic building blocks. We can expand on this certainly in much more detail, but these are the basic building blocks of application modernization. So let's talk about an example. Let's talk about just one example as time allows for us here. A bank in the Netherlands, a financial institution by the name of SNS. Some of you have heard of SNS Bank, a very large institution. This group was running its core banking portfolio on a Unisys mainframe. And this was creating a lot of challenge for the bank because of many of the things we discussed earlier. The expectation that the bank was going to deliver new services to its customers, the expectation that the IT team was going to respond faster to that incoming set of changes, pressures to reduce cost and become more efficient within the enterprise. All of these things were coming together to create an environment where they could no longer stay on that environment. They could no longer stay with that infrastructure because it was inflexible to this rapid pace of change. So they looked at alternative models. They looked at working with IBM because they had IBM expertise in-house through the global services team. And they looked at some tooling, several different tools around application modernization. They chose to rehost for the same reason that UK retailer chose to rehost. Competitive advantage. They could reuse 100% of their banking application portfolio, but just change the infrastructure. Give themselves a platform on which they can now be much more adaptable. Moving to more of an open environment now gives them a lot more flexibility. They can modernize those systems. Their expectation now is to be able to provide better interfaces for their partners using standard-based tools such as REST and JSON and other SOA-based technologies. Now they can open up their application in a secure way to those that need to interact and access that data. They didn't have that capability before. And this is all driven on SUSE Enterprise Linux. So there's lots of choices here. There's lots of choices when we talk about application modernization. What we want to leave you with is an understanding that as you look at those choices, understand the trade-offs. Understand that certainly application rewrite and replacement will get you to your goal, but it's not always the fastest path, particularly where there's core IP at stake and there's core intellectual property you want to preserve. There are other ways to modernize those systems. In many cases, reuse is one way you can get there faster and get there faster with greater predictability. So if this is something that's interesting to you, we hope the the lecture here has been informative for you, giving you some insight into how to modernize core systems. We'd love to talk to you a little bit more about this. Stefan's here throughout the week. He's going to be speaking later today, a little bit more around LinuxONE. I'm here throughout today as well, so I'd love to chat with you more about this if you have specific questions. But I think we do have a few moments. If you have any specific questions now, we can answer.
Also, if you are interested in the hardware platform, more at the IBM booth, there is a glass model from a rock hopper. You can really see it inside the architecture, and there's also someone who can explain in glorious details about the systems.
Absolutely. Any questions we can answer in the remaining time? The folks in the room? Was this helpful for you? Give you a little insight into this technology? Yep, sure.
So the Java bytecode, is that IBM Java? What any Java version or any variant of Java is that bytecode can run on?
Any platform that will run a JVM.
Okay.
So it could be desktop, it could be web, it could be application server. So anyone that will run a JVM, and I mean most we see is Oracle, right? But I mean there are other JVMs. So as long as it runs a JVM.
And I'm thinking like OpenJDK versus IBM JDK or JVM.
Mm-hmm. Yep.
Or
Sure.
Thank you.
No problem.
Thank you.
All right, thank you.